Welcome. I'm Bruce, and this video explains an oil field innovation that allows you to drill and complete 2 wells for the price of 1. Lower costs and the added value of additional production can significantly affect your company's return on investment and cash flow. This is a simple drawing of the innovation that we will explain. The top looks down on a typical borehole. Casing has been run in the borehole and cemented in place. Subsequently, a completion has been run. The bottom elevation view is a cross-section through the subterranean strata and well. Also, a quarter section is removed from the completion in the elevation view so that you can see the outside of the completion on the left and the inside of the completion on the right. First, let's start from the bottom of the well and work upwards. Oil and gas wells can be very complex or very simple. We have included a great deal of detail here so as to explain our tool to a wide audience. Oilfield Innovation's Multi-Production Injection Crossover Tool, or MPIX tool, can comprise only a weldment with no moving parts for the simplest wells, or, for more complicated wells, it can include field-proven completion jewelry from any vendor of your choice. Cased hole completions, like the ones shown here, typically use guns to perforate holes into the casing adjacent to the production zone. In this example, we show production from the lower reservoir in yellow. Subhydrostatic wells, incapable of flow without stimulation, can have an open annulus passageway, whereas wells capable of natural flow will typically require barriers to protect the environment. Conventional environmental protection from a reservoir capable of naturally flowing hydrocarbons to surface generally comprises a tailpipe which extends from a production packer. Together, the packer and tubing isolate the lower reservoir from the other environments above it. Our MPIX tool uses a production packer to isolate differently pressured zones, or reservoirs, within any well, including wells that normally hang the tubing in the casing without a production packer and, hence, can only access one zone at a time without losing production to crossflow. For differently pressured reservoirs, or if layers within a perforated interval deplete at different rates, and a packer and tubing are not present to isolate the zones, crossflow could cost your company a significant value since production from a higher pressure zone will be lost into a lower pressure or depleted zone. Alternatively, for water and steam floods, while it's physically possible to inject through the tubing and produce through the annulus of a well, it is not conventionally considered to be safe. The injection of water or steam stimulates flow of combustible hydrocarbons from the upper reservoir, which cannot be controlled with conventional equipment if, for example, the single barrier leaks. Our MPIX tool can use either a permanent or retrievable packer on the bottom of production tubing to isolate an upper zones or reservoir's production or injection from a lower zone or reservoir with a different pressure regime to prevent crossflow between the two zones. In this example, the differences in pressurized production or injection are represented by the yellow color within the completion, which is connected to the lower reservoir, and the green color connected to the upper reservoir. A subsurface safety valve is a reliable conventional means of controlling the flow within the tubing. As shown in this optional configuration, the upper reservoir flow, shown in green, is unaffected by the subsurface safety valve controlling the yellow flow associated with the lower reservoir. Most subsurface safety valves use a flapper that closes across the internal diameter of the tubing to substantially stop flow. Our MPIX tool crosses the flow over from the annulus to the tubing and from the tubing to the annulus. As shown, the lower reservoir can be controlled by the lower subsurface safety valve, and because the flow from the upper reservoir, shown in green, will be crossed over from the annulus to the tubing, another subsurface safety valve can be used at the top of the MPIX tool to control flow from the lower reservoir. The MPIX tool is an assembly that can be 8 to 10 meters or 24 to 45 feet in length, depending upon the customer's needs and the desired optional features. Our MPIX tool uses upper and lower chambers to direct flow to or from the tubing and an intermediate annular flow path positioned between the tubing and the annulus outside of the MPIX tool. The MPIX tool's chambers are sealed with seal caps and can house optional customer-specified equipment like tubing couplings to provide service brakes and sliding sleeves to provide additional flow control or to replace the subsurface safety valves. One of the unique features of the MPIX tool is the ability to maintain through tubing access to the lower end of the well. Ports cross over flow from the lower reservoir and inside diameter of the tubing to the intermediate annular passageway and are shown as a sliding sleeve in this example. Alternatively, crossover ports can be orifices that remain open and can be covered by a wireline run sleeve. While the MPIX tool is operating, the internal diameter of the tubing above these ports, shown in white, is not used for flow because it is needed for accessing the lower end of the well. The diameter of the chamber housing the crossover ports that facilitate flow between the tubing and intermediate annular passageway can be enlarged to house customer completion jewelry via a swedge shown here. Alternatively, the swedge would not be used and the chamber size would be reduced if the customer does not need additional completion jewelry. The lower chamber of the MPIX tool is attached to the upper portion of the MPIX tool using an API or premium coupling. After the upper end of the MPIX tool is passed through the customer-supplied completion hanger packer. Any conventional uncemented scab liner hanger packer that maximizes the flow area within its internal diameter, like the Baker Hughes high flow hanger shown here, can be used with our tool. Obviously, the hanger packer's internal diameter can represent a flow restriction for the MPIX tool in various circumstances, but the cross-sectional flow is manageable in most cases. First, let's look at the scenario where the customer wishes to maximize the diameter of the internal tubing access so that, for example, large diameter tools can be conveyed through the tubing to the bottom of the well on wireline. In this example, the full diameter in 3 square inches cross-sectional area of the 2 3/8 inch tubing is available, with the intermediate annular passageway from the lower reservoir also having a 3 square inch cross-sectional flow area, while the outer annular flow associated with the upper reservoir is restricted to 2.3 square inches of cross-sectional flow area. Now let's look at the scenario where the customer's access requirements are limited to using, for example, 1 1/4 inch diameter wireline tools. As shown here, a smaller diameter API tubing can be used. The flow areas from the upper and lower reservoirs are 3.9 and 3.8 square inches respectively. By using the smaller tubing within the MPIX tool, which does not limit flow since it is only used for wireline or coil tubing access, the cross-sectional areas can be made greater than the flow area of the 2 3/8 tubing used above and below the MPIX tool to reduce the velocity and possible erosion through the MPIX tool. Our MPIX tool can be sized to meet your reservoir's flow requirements using API tubing. So let's look more about how it works. The production packer at the bottom of the well separates the differently pressured upper and lower production and/or injection zones, while the conventional hanger packer fitted to the MPIX tool separates differently pressured annuli above and below its packer element. Proven conventional hanger packers, like the Baker Hughes high flow hanger shown here, can have J-slot mechanisms that allow you to tension the completion tubing above the MPIX tool. The MPIX tool is attached to the hanger packer using a special clearance high-strength coupling that can, for example, be used to change the hanger packer during a workover. Our MPIX tool can use 2 API tubing strings passing through the hanger packer to provide 2 segregated simultaneous flow streams and an internal passageway for accessing the lower end of the well. Now let's look at the crossover, which is at the heart of our patented apparatus method. Flow from the intermediate annulus, shown in yellow, travels through a sealed passageway between the intermediate annulus and the outer annulus above the hanger's packer element. Flow from the annulus below the hanger's packer element, shown in green, travels between the hanger packer and the MPIX tool around this sealed passageway into the upper chamber of the MPIX tool. crossover portion of the MPIX tool crosses flow, shown in yellow, from the lower reservoir through the tubing to the lower MPIX tool chamber and finally to the annulus above the hanger packers element. It also crosses flow, shown in green, from the annulus below the hanger's packer element to the upper chamber of the MPIX tool and the tubing above the MPIX tool. Accordingly, flow in the annuli and tubing is crossed over while retaining internal tubing access to the lower end of the well. The tubing internal diameter between the optional sliding sleeve valve and the plug and prong is shown in white to signify that it cannot be used for flow when a plug and prong are present. There are, however, instances where a plug and prong would not be present from the start when, for example, customers want large 5.5-inch production tubing within 9 5/8-inch casing to maximize initial production and later use the MPIX portion of the completion for zonal water shutoff and a velocity strain. Initially, the MPIX tool may not use a plug and prong to produce from the same reservoir and commingle flows when the water cut is low. Later, when the water cut increases, a customer can use wireline to set a plug and prong within the MPIX tool. Doing so effectively shuts off water production from the lower portion of the reservoir. Lower water cut production from the upper portion of the same reservoir can then continue through the MPIX tool's internal velocity string, while huff and puff operations can be used on the lower portion of the reservoir. Cross-flow of segregated simultaneous flow streams and access to the lower end of the well is facilitated by conventional plug, prong, and nipple arrangement, which separates the flow streams but can be removed to access the well's lower end. The MPIX upper chamber's flow ports can be closed by, for example, installing a sliding sleeve over the ports, or by closing the sliding sleeve valve prior to removing the plug and prong to prevent cross-flow once the plug and prong have been removed. The MPIX tool's upper and lower chambers provide the ability to stop cross-flow to and from the tubing and can be used to house customer completion jewelry. The ends of the chambers are sealed with a cap, and the chambers have service brakes so that the equipment within the MPIX tool can be serviced. As shown previously, an optional subsurface safety valve can be placed on both ends of the MPIX tool to control two segregated and simultaneous flow streams. That completes our overview of Oilfield Innovation's patented multi-production injection crossover tool, or MPIX tool. I hope that we've been able to provide you with the necessary insight to understand how you can get 2 wells for the price of 1. The explanatory graphic used here can also be found on our website if you'd like to study it further. Also, feel free to contact us if you have any questions. Thank you for watching our video presentation.